In this video, we answer the question, what are the truth definitions for the biconditional? To facilitate our work, we're going to do a little bit of review, beginning with the concept of a truth value. A sentence that is true or false has a truth value. In other words, a sentence's truth value is its truth or falsity. If you don't have a key to the door, you can't get into the room, and if you can't get into the room, then you don't have a key to the door. Having a key to the door is a necessary and sufficient condition for getting into the room. You get into the room if, and only if, you have a key to the door. Notice that these are sentences governed by the biconditional. Remember also that, in propositional or sentential logic, statements are compounded by connectives. We've got the negation, conjunction, disjunction, conditional or material conditional, and biconditional or material equivalence. The common symbolic notations are as follows. Of course, our focus is on the biconditional or material equivalence, and that connective is symbolized most commonly by the two-way arrow or the triple bar. The symbolic logic notation for the connectives operate on sentences, whether they are simple, that is, irreducible, or compound. In other words, the operator does something to the sentence on which it operates, or it does something to the sentence it governs. The dryer works if and only if the power is on. If you don't have a key to the door, you can't get into the room, and if you get into the room, then you have a key. Going on a hike is a necessary and sufficient condition for my happiness. The dryer works just in case the power is on. Determining under what conditions each of these sentences is true and under what conditions each is false requires that we know the possible truth values of the simple sentences, along with the truth definitions of the operators and the order of applying those definitions to sentences with multiple operators. Again, our focus is on the biconditional. So let's talk about its truth definition. An operator is defined by the truth value of the sentence upon which the connective operates, along with the meaning of the connective itself. Remember, we're focusing on the biconditional, whose function is to affirm that both or neither is the case. So when we're saying both or neither, we're talking about each side of the two-way arrow or the triple bar. Let's take a look at how this works. One way we can think about the truth definition is in terms of an answer to the question, how do I know if the sentence is true or false? A biconditional is true when each of its constituents have identical values. Otherwise, it's false. Let's go ahead and look at an example to help us see what we're talking about. Let's suppose we have the following statement. I earn an A if and only if I have scored a 90 or above. In other words, what we're saying is that earning an A guarantees getting a 90 or above, and getting a 90 or above guarantees earning the A. Now let's consider row 4. It's false that you earn an A, and it's false that you earn a 90 or above. It's still true, however, that when you earn an A, you've got a 90 or above, and when you have a 90 or above, you have an A. On the other hand, when the values do not match up, that is, when one side of the biconditional is true and the other is false, or one side of the biconditional is false and the other is true, you end up with a value of false. Here's another way to think about it. When the truth values are identical, we're saying that the sentences, in this case P, Q, are truth functionally equivalent. I hope this video has helped you understand the answers to the question, what are the truth definitions for the biconditional?